their first taste of freedom. Researchers are releasing several Przewalski horses into the wild.
It's the only truly wild horse on Earth.
A barren stretch of desert in China seemed like the last place anyone would choose for a wildlife experiment. There was little vegetation, scarce water, and almost nothing that suggested life could thrive there. Yet scientists made a surprising decision. They released a group of rare wild horses into this unforgiving landscape and waited to see what would happen. What followed challenged expectations and revealed something remarkable about nature's ability to recover when given the chance. The Desert Challenge. Nobody expected them to survive. In late 1986, a bold experiment began in one of the most unforgiving environments in China. A small group of 11 rare wild horses was transported into a remote desert region where survival itself seemed unlikely. The landscape offered little comfort. Water was scarce, vegetation was limited, and temperatures swung between freezing winters and scorching summers. To many observers, the outcome appeared obvious. Few believed the animals would last long. These were not ordinary horses. Known as Przewalski's horses, they represented the last truly wild horse species on Earth. Their stocky bodies, upright manes, and remarkable toughness had once allowed them to roam across vast grasslands and deserts. But there was a problem. For generations, these horses had lived under human care. Zoos provided food, shelter, and protection. The skills needed to survive in the wild had not been tested for decades. Now they were being asked to face a landscape that had become increasingly hostile, even to people. Researchers understood the risks, yet they also believed the horses might play a role far greater than simply surviving. Historical records suggested that wild horses had once moved freely through these regions. For thousands of years, they traveled across open land, grazing, dispersing seeds, and shaping ecosystems without anyone realizing how important they were. Then, they disappeared. As the years passed, the land changed. Soil became compacted and difficult for rainwater to penetrate. Plants struggled to grow. Dust storms became more frequent. Areas that once supported life gradually turned barren. Efforts to reverse the damage had limited success. Trees were planted, barriers were built, various restoration projects were attempted. But much of the landscape continued to deteriorate. Some scientists began asking a different question. What if the missing piece was not another machine or engineering project? What if the answer had 4 legs? The idea may have sounded simple, but the reasoning was surprisingly strong. Horses constantly move across large areas. Their hooves break up hardened soil, creating openings that allow water to soak into the ground. They spread seeds as they travel and naturally influence vegetation patterns. Even their waste returns nutrients to the environment. If the horses could survive, they might help the land recover as well. Still, survival came first. The desert wasted no time testing them. Winter arrived with brutal force. Bitter winds swept across the landscape. Snow buried the limited vegetation that remained. Temperatures dropped far below freezing. Several horses became ill, and some pregnant mares lost their foals. From a distance, the experiment seemed to be heading toward disaster. Then something unexpected happened. The horses began displaying behaviors no human had taught them. They scraped away snow to reach food. They broke through ice to access water. During storms, adults gathered around younger animals for protection. Instincts that had remained hidden for generations suddenly resurfaced. The horses were adapting, and as they settled into their harsh new home, researchers started noticing subtle changes that no one had anticipated. The animals were surviving, but the desert itself might also be beginning to respond. What happened when winter finally loosened its grip would surprise even the people leading the project. The first signs the desert was changing. When the long winter finally ended, researchers returned expecting damage and loss. Instead, they noticed something subtle but unusual. In several areas where the horses had moved, Faint patches of green had begun to appear. At first, it looked accidental, a small coincidence. But as days passed, those patches became more noticeable. The ground itself seemed different. Every step the horses took pressed into the hardened soil, leaving behind small indentations. These tiny marks began to matter more than anyone expected. Rainwater that once ran off the surface now lingered longer in these spaces. Moisture stayed trapped just enough for dormant seeds to awaken. What had looked lifeless was slowly reacting. Soon, plants that had not been seen for years started returning in scattered clusters. The soil, once dry and sealed, was beginning to breathe again. Researchers tested it and found slight increases in moisture and nutrients. It was not a dramatic shift, but it was enough to signal that something was changing beneath the surface. Then the ecosystem began to respond. Insects appeared first, especially dung beetles, breaking down waste and returning nutrients back into the soil. That small process triggered a larger chain reaction. Other insects followed. Then birds arrived, drawn by the growing insect population. With food becoming available again, small mammals cautiously returned. Each return added pressure to the next change. By the time the horses were fully released into larger wild zones in 2001, the experiment had already shifted from survival testing to ecological transformation. One stallion, later observed leading a group across unfamiliar terrain, moved with surprising confidence. Without guidance, he eventually brought the herd toward a hidden water source, a discovery that left scientists questioning how such navigation was even possible. It felt as if something deeper than training or memory was guiding them. As the horses spread further across the landscape, researchers realized they were no longer just observing survival. They were watching the beginning of a system rebuilding itself from within. And what they discovered next would reshape how they understood the entire history of these horses and why they almost disappeared in the first place. The horse that almost disappeared from history. There was a time when Przewalski's horses roamed freely across vast stretches of Central Asia. They moved through grasslands, deserts, and open plains, perfectly adapted to harsh climates and unpredictable conditions. But over time, their presence in the wild began to fade. By the modern era, the situation had become critical. The species was no longer surviving in natural habitats. At one point, it was officially declared extinct in the wild. The only remaining individuals existed inside zoos, carefully protected but far removed from the environments they were meant to live in. This created a dangerous problem. Animals raised in captivity often lose survival instincts over generations. Without exposure to predators, weather extremes, and food scarcity, their ability to function in the wild becomes uncertain. For Przewalski's horses, this risk was even greater because they were not domesticated horses that had adapted to human life. They were the last true wild horse species on Earth. Physically and genetically, they stood apart. They were smaller, stockier, and built for endurance. They also carried 66 chromosomes, unlike domestic horses, which have 64, confirming they were a completely distinct lineage that had never been domesticated. So how did they end up so close to disappearing? The answer was a combination of pressures. Hunting reduced their numbers drastically. Competing livestock consumed the grass and water sources they depended on. Expanding human settlements fragmented their habitat. On top of that, young foals were captured and transported to zoos, further weakening wild populations. By 1969, the last confirmed sighting of a wild Przewalski's horse was recorded. After that moment, none were seen in their natural environment again. Survival depended entirely on captive breeding programs scattered across the world. But even that was not simple. Genetic diversity was extremely limited. Scientists estimate that all modern populations descend from just a small number of founders, creating a severe genetic bottleneck. This meant long-term survival was never guaranteed, even in captivity. Despite the odds, international conservation programs continued for decades. Zoos exchanged animals, managed breeding carefully, and slowly increased population numbers. Over time, hope returned, where extinction once seemed final. But rebuilding numbers in captivity was only the beginning. The real question remained unanswered. Could a species that had spent generations behind fences truly survive in the wild again? That question would soon be tested in one of the harshest landscapes chosen for their return. When nature began to repair itself. Bringing Przewalski's horses back into open land was never just about saving a species. It quickly became something much bigger. It became a test of whether a damaged ecosystem could respond when a missing piece was restored. The early years were not easy. Some horses did not survive the harsh winters. Deep cold, sudden storms, and limited shelter pushed many to their limits. Others faced threats from predators such as wolves. In certain regions, human-made roads cutting through natural habitat created additional dangers, leading to accidents and fragmented movement patterns. Even water sources were not always safe. Some contained high mineral levels that made them difficult to drink over long periods. Yet despite these challenges, the horses adapted. They formed structured social groups called harems, where one dominant male led several females and their young. This structure increased their chances of survival, especially during harsh weather and long migrations in search of food and water. Over time, their behavior became more refined. They learned where to find water without guidance. They adjusted movement patterns based on seasons. And during winter, they developed the ability to dig through snow and frozen soil to reach buried vegetation beneath the surface. But something else was happening at the same time. The land itself was beginning to shift. As the horses grazed, they prevented certain plant species from dominating the landscape. This created space for other plants to grow, increasing overall biodiversity. Seeds attached to their fur or passed through digestion were carried far across the terrain, spreading vegetation into new areas. Their manure added nutrients back into poor soils, slowly improving fertility in patches where plants could take hold again. Even their movement created natural pathways used later by other animals, including foxes, gazelles, and smaller mammals. Gradually, researchers began to describe them differently. They were no longer just animals being reintroduced. They were becoming ecosystem engineers. Every movement, every feeding pattern, every migration route started influencing the structure of the environment around them. Plants returned, insects followed, birds appeared, and soon, predators returned to complete the cycle. A broken system was quietly reconnecting itself. And as scientists watched this chain reaction unfold, they began asking a new and even more important question. If one species could reshape an entire desert ecosystem like this, what would happen if even more horses were released into the wild at a larger scale? The turning point in the desert experiment. In 2001, the experiment reached a critical turning point. After years of controlled care and gradual preparation, 27 Przewalski's horses were finally released into a protected desert reserve in China. This time, there would be no safety net, no daily feeding, no protective fences guiding their movement. They were expected to survive entirely on their own. At first, hesitation was clear. The horses stayed close to the release area, moving cautiously as if testing whether the world beyond still felt dangerous. Every step seemed uncertain. The desert was familiar in appearance, but completely unfamiliar in experience. For animals raised with human support, independence was not immediate. Then a shift began. A strong stallion eventually took the lead. Instead of staying near the release point, he began moving deeper into the desert step by step. The rest of the herd followed his direction, slowly at first, then with growing confidence. Their movement was not random. It felt guided, even deliberate. Days later, the group made a discovery that stunned researchers. They reached a hidden water source that had not been recorded on any maps or known surveys of the area. No human had guided them there. No tracking system had pointed the way, yet somehow they had found it. This moment changed how scientists viewed the entire experiment. It raised a question that had no simple explanation. Were these horses relying purely on instinct, or was something deeper at work? Perhaps a form of environmental memory passed through generations. As the herd settled into larger territories, their behavior continued to evolve. Wild-born foals began showing noticeable differences. They reacted faster to threats, learned survival skills more quickly, and appeared more adapted to harsh conditions compared to those born in captivity. At the same time, subtle changes in the landscape became harder to ignore. Vegetation started appearing more consistently in areas where the horses grazed and traveled. Soil conditions improved, holding moisture for longer periods than before. Each observation pointed to the same idea. Something in this environment was starting to respond to their presence. And as researchers expanded their monitoring across wider regions, they began to realize that what they were seeing might not be limited to a single reserve anymore. Larger patterns were forming across the desert itself, suggesting that something much bigger was beginning to unfold beyond the original experiment. The desert crisis that forced a national response. Across the northern regions of China, vast stretches of land once supported life. These areas were not always empty or lifeless. They once held grasslands, scattered forests, and fertile soil where farming communities could thrive. Animals moved freely, and the land provided enough resources to sustain both people and nature. But over time, that balance began to break. Human activity placed increasing pressure on the environment. Large numbers of trees were cut down for fuel, construction, and expansion of farmland. At the same time, grazing animals such as goats, sheep, and cattle consumed vegetation faster than it could recover. Without enough plant cover, the soil became exposed and fragile. Once the protective layer of vegetation was gone, the land began to degrade quickly. Wind and rain carried away the topsoil, stripping away nutrients that plants needed to grow. What remained was dry, loose earth that could no longer support strong vegetation. Slowly, productive land started transforming into barren desert. This process did not happen overnight, but it continued year after year, expanding further into once fertile regions. Entire farming areas began to disappear under drifting sand. The consequences spread far beyond rural zones. Sandstorms became more frequent and far more intense. Strong winds carried dust across cities, turning skies yellow and reducing visibility to almost nothing. Transportation was disrupted, schools were closed, and daily life was repeatedly affected. In some cases, storms were so severe that people were forced to stay indoors for days. Health problems also increased, especially respiratory conditions caused by fine dust particles in the air. By the late 1970s, the situation had become too serious to ignore. In response, the government launched a massive national restoration plan designed to slow and eventually reverse desert expansion. The project focused on large-scale tree planting across northern regions, aiming to create a continuous green barrier that could stabilize the land. This initiative stretched across thousands of kilometers and involved planting billions of trees over time. The strategy was not simple. Early efforts faced high failure rates, as many young trees could not survive the harsh climate. However, over time, improved techniques were developed. Water harvesting methods were introduced, including small ground structures designed to trap rainfall and reduce runoff. Drought-resistant tree species were also selected for better survival rates. Gradually, small patches of green began to appear in areas that were once completely barren. But even as progress slowly continued, a deeper question remained unresolved. If massive planting efforts could not fully restore balance on their own, what else was missing from the system? And somewhere far from these restoration sites, an unexpected answer was already beginning to reveal itself through the movement of animals across another part of the desert, hinting that the solution might not come from machines or trees alone, but from something far more natural and alive. The final truth behind the Great Restoration effort. Over the following decades, the massive tree planting campaign began to show visible results. Areas that were once nothing but shifting sand slowly started to transform. In some regions, grass returned first, followed by shrubs, and eventually small patches of forest. What had once looked lifeless was beginning to show signs of recovery. The most immediate success was the reduction of sandstorms. As vegetation grew stronger, it helped anchor the soil and reduce the force of wind at ground level. Dust storms that once regularly disrupted cities became less frequent and less intense. This improvement brought clear benefits to public health, transportation, and daily life. Farming conditions also improved in certain areas as the soil became more stable and less prone to erosion. Economic opportunities began to appear as well. Tree planting programs created jobs, and some restored areas were even used for agriculture and tourism. Land that was once considered unusable slowly regained value. However, the progress came with serious challenges. One major issue was water consumption. Many of the planted forests were located in regions with very limited rainfall. As trees matured, they required more water than the environment could naturally provide. In some areas, groundwater levels began to drop, raising concerns about long-term sustainability. Another problem was lack of biodiversity. Large sections of the forest consisted of a single tree species, which made them vulnerable. If pests or disease spread through one type of tree, entire sections of forest could be at risk. To address these concerns, scientists adjusted their approach. Mixed forests were introduced, combining different species of trees, shrubs, and grasses to create more stable ecosystems. More efficient irrigation methods were also developed to reduce water loss. In some cases, drought-resistant plants were prioritized to better match the natural conditions of each region. Despite the difficulties, the transformation continued. What once seemed like irreversible desert damage was now slowly being pushed back. Yet the biggest lesson was not just about planting trees or stopping sandstorms. It was about understanding that restoring nature requires balance, patience, and the right combination of living systems working together. And as researchers looked back at everything that had happened, one final realization stood out more than anything else. The desert was never truly empty. It was waiting. Thank you for watching this journey through China's desert transformation and the return of wild horses. If you enjoyed it, please like, subscribe, and comment your thoughts below. Watch the next video for more incredible real-world stories.